This is Unit 2, Section 1, our second day of looking at quadratic functions, day 2 of Section 2.2, and we are going to graph. So our steps for graphing a quadratic will be find and graph the vertex. So depending on what kind of form it's in, that's going to change how we find the vertex, and we'll go over each form individually. Then, if it's standard or vertex form, we're going to plot up to 3 additional points on either side symmetrically. We're going to find these points by multiplying 1 times a, 3 times a, and 5 times a. This will tell us how many spaces we need to go up or down after moving over 1 each time. For intercept form, the only other points we're going to have to graph are the x-intercepts. And then we're going to connect our points in a U shape. We're going to try our best not to make it look like a V, but look like a U. So to find the vertex in vertex form, we've already discussed this because it's h comma k. It comes directly from the form. We take the opposite of what's in with the x and the exact number of what's outside for the y. So the vertex is h comma k. So let's graph this quadratic that's given to us in vertex form. And then we're going to identify as much of this as we can. So the vertex we can pull out immediately. The vertex is opposite of 2, negative 2, comma positive 9. So I'm able to graph negative 2, positive 9. Then I'm going to multiply 1 times a, 3 times a, and 5 times a. In this case, a equals negative 1. So we do 1 times negative 1, 3 times negative 1, and 5 times negative 1 to get negative 1, negative 3, and negative 5. This means when I go over 1, I should be going down 1. And then when I go over 1, I should be going down 3. And then when I go over 1, I should be going down 5. I'm going to do the same thing on the left side. Over 1, down 1. Over 1, down 3. Over 1, down 5. Right? That was the 1, the negative 1, the negative 3, negative 5. And I'm going to connect my dots and make it look like a U the best I can. And put arrows on both sides. So that's my graph. The axis of symmetry we know is always through the x value of the vertex. So my axis of symmetry is x equals negative 2. The maximum or minimum, so this is the highest point, so there's a maximum value of 9 when x is negative 2. The intercepts, so I can actually see both x-intercepts and I can see the y-intercept. So my x-intercepts are going to be negative 5, 0, and 1, 0, right here and here. And my y-intercept is where it crossed the y-axis at 0, 5. Increasing and decreasing intervals. So it's increasing or going up to the vertex on the left, so when x is less than negative 2, and it's decreasing or going down when x is greater than negative 2. The domain was all real numbers, and my range was everything below this 9, so y is less than or equal to 9. So you're going to try the next one, pause, and I'll show the answer. Okay, so for this one, our vertex was 4, -7. The axis of symmetry was x equals 4. The minimum value was -7 when x was 4. We couldn't identify any of the intercepts. We could tell that it happened probably somewhere between 1 and 2 and somewhere between uh, 6 and 7, but beyond that we can't tell exactly from this graph. We also don't see the y-intercept yet. If I continued, I would eventually get up to 9, but we didn't see it on the graph, so I didn't list them because it just said if possible. It was decreasing to the left and increasing to the right. Domain was all real numbers, and the range was y is greater than or equal to -7. Our next form is intercept form. So intercept form, they give us the two intercepts. So the average of the intercepts, or directly in the middle of the intercepts, is going to be the x value of the vertex, and then we plug that back in to find the y. All right, that also means the axis of symmetry is p plus q over 2. Notice we're taking the opposite signs of both. All right, so for this one, my x-intercepts, I'll start with that, would be 3, 0, and -1, 0. So those are here and here. So I need to find exactly in the middle of 3 and -1. So if I add them together and divide by 2, I get 1. So that means my axis of symmetry is x equals 1, and in my vertex, the x value is 1. To find the y value, we're going to take 1 and plug it back in. So that's 2 times 1 minus 3 times 1 plus 1. That's 2 times -2 times +2, and we get -8. So that's the value of my vertex. I don't have to graph any other points. I'm fine with the ones I have. Although I could always check by making sure it's going 1 times 2, 3 times 2, 5 times 2. And in fact, when we do that, we do see that that point existed, so we know our y-intercept. All right, so the vertex we've identified, the axis of symmetry we've identified, the maximum or minimum. So that's a bottom point, so it's a minimum of -8 when x is 1. The intercepts, we mentioned our x-intercepts. Our y-intercept we can also see at 0, -6. Increasing and decreasing intervals. So it's decreasing to the left, so decreasing when x is less than 1, and increasing then when x is greater than 1. And now my domain and range. So domain is all real numbers. Range, it's above this 8, this -8. So y is greater than or equal to -8. So you go ahead and try this one, pause, and I'll show the answer. Okay, so there's our graph. We had x-intercepts at 4, 0, and 8, 0, an axis of symmetry at x equals 6, a vertex of 6, -2, a minimum of -2 when x equaled 6. It was decreasing when x was less than 6, and then increasing when x was greater than 6. My domain was all real numbers, and my range was y is greater than or equal to -2. Our last kind of form is standard form, and this is the one that does take the most work. So standard form, right, ax squared plus bx plus c. So we're going to take the opposite value of b over 2 times a, and that's the x value of our vertex, and then we still have to plug it back in to find y. So in this example, my A is negative 3 and my B is positive 6. So when I go to do negative B over 2A, that's going to be negative 6 over 2 times negative 3. So that's a negative 6 over a negative 6, or 1. And I'm going to plug the 1 back in. So positive 1 squared is 1, times negative 3 is negative 3. Positive 1 times 6 is 6, plus 7. So that's 13 minus 3 is 10. So my vertex is 1, comma 10. My axis of symmetry is x equals 1. I'm going to graph that. We have 1, comma 10. I have an a value of negative 3, so that means we're going to be doing 1 times negative 3, 3 times negative 3, and 5 times negative 3. Chances are we're not going to fit them all. So that's negative 3, negative 9, and negative 15. So from this dot, when I go over 1, I'm going to go down 3. Do it on both sides. Then I'm going to go down 9. So over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to do the same thing on the other side. I'm not going to be able to fit that 15, so that's fine. Try the best we can here. All right. So I've identified my axis of symmetry and my vertex. There's a maximum of 10 when x equals 1. We have x-intercepts we can't quite see, but we do have a y-intercept we can identify, right? And we knew it from here because we know in quadratic, in standard form, the c value is my y-intercept, so that's 0, 7. Increasing and decreasing, so it was actually increasing this time when x was less than 1, and it's decreasing when x is greater than 1. My domain is all real numbers, and my range is now y is everything below, so y is less than or equal to 10. So you go ahead and try this one, pause it, and I'll show the answer. All right, so for this one, our vertex was negative 5, negative 3. The axis of symmetry was x equals negative 5. There was a minimum of negative 3 when x equals negative 5. Even though we can't see it on the graph, we know it from the equation that our y-intercept would be at 0, 22. It was decreasing when x was less than negative 5 and increasing when x is greater than negative 5. My domain was all real numbers, and my range is y is greater than or equal to negative 3. A lot of times we have these quadratics, they actually apply to real-world problems. So here we have the path of a diver, and they mean like somebody on a diving board, can be modeled by the function f of x equals negative 9x squared plus 9x plus 1, where f of x is the height of the diver in meters above the water, and x is the horizontal distance in meters from the end of the diving board. So we want to know, what is the height of the diving board? Right? The height of the diving board is its starting value. Where is the diver starting from? And we know we start always at our y-intercept. So since this is written in standard form, we know where our y-intercept is, right? It's our c value. So he's starting from 1 meter. Then they ask, what is the maximum height the diver reaches? So we know max refers to the y value of the vertex. So we're going to have to find the vertex of this equation. So we know we're going to start with negative b over 2a to find x. B is positive 9, so that's negative 9 over 2 times a. A was negative 9. So this becomes negative 9 over negative 18, or 1/2. And if you'd like, put that into 0.5. Recall, we have to plug it back in. So we're going to get negative 9 times 0.5 squared plus 9 times 0.5 plus 1. So this ends up being negative 2.25 plus 4.5 plus 1, which is about 3.25 meters. All right, and that's the maximum height he reaches. Another kind of problem we can have, they're telling us the parabola in this graph shows the path of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot can be modeled by the function f of x equals negative 0.02x times x minus 80. Which shot travels farther before hitting the ground? Which travels higher? So if we're looking for farther, we're talking about the distance between the intercepts. I can't fit the word. Between x-intercepts. So for our first graph, we could see we started at 0, 0 and ended at 100, 0. So that was a distance of 100 yards. My second function can actually be rewritten into intercept form. This x is really saying x minus 0, and the second one was x minus 80. So we're really finding the difference between 0 and 80. So my second shot traveled 80 yards. So we can already answer the first one. Which shot traveled farther? The first shot traveled farther. Right? Because it was 100 yards compared to 80. Then we want to know which one travels higher. And higher, we're talking about the y value of the vertex. Right? That's talking about our max height. So if we want to know which one travels higher, well, the first one showed me it had a y value of 25 yards. For my second one, I'm actually going to have to find the vertex. So we know x is going to equal 0 plus 80 over 2, which is 40. And then we're going to plug 40 back in. So 40 minus 0 times 40 minus 80. So if we were to do the math here, we end up with a distance of 32. So now, comparing which one travels higher, the second was higher, because 32 is higher than 25. All right, we can't just go ahead and answer these without showing our documentation, but this is our final answer. This is documenting that answer. So you're going to try the last one. You can pause, and I'm going to show your answers. All right, so for this one, the first one traveled 40 units far, right? We get that by doubling the 20 from the vertex, and it traveled 8 high. The second one went 50 far, because that went from 0 to 50, and 5 high if I were to find the vertex. So my first one traveled higher, but my second one traveled farther. All right, and that is day 2 of quadratics.